Hey folks, Adam Hiley here, and it's back, the Formbot T-Rex 2 Plus. I've had this for a few months now, so I got it back in October, and it's been great. I'm sorry I haven't gotten a video out, as everyone's been screaming for me to do, with thoughts and sort of a more formal review of this. Not for lack of wanting to, not for lack of using it by any means. I've been pretty busy with it. But I've also been sort of busy doing modifications on it, which I'll get into in a second, and evaluating every possible thing I can. And, you know, that's just, I'm more the type to work on something than necessarily think about filming it. But, yeah, so as you may have noticed, it's in a different location from where it was in my last video when I unboxed it. That's because I didn't really want to keep it on my desk forever, and I've got this, oddly enough, closet in my house with a desk, which is probably out of frame right here. It was a perfect spot to put it. I had to turn it sideways though, because the y-axis on this moves in and out, and obviously that would hit the back wall and hit the door. I actually print this with the doors closed, because these all come in and shut, and I've sealed all around the doors. It acts as a nice heated build chamber for this. It's 800 watt heated bed, so that really gets everything nice and toasty. I've seen about 95 degrees in here when it's 70 degrees in the rest of the house, so it's not too bad. So, initial impressions on the printer. As you probably will have seen from my previous video of assembling this, it was relatively easy to set up, aside from my general pedantic ways of going through everything 15 times. You know, I got it together in about 2.5 to 3 hours start to finish, and that was while trying to film it and talk to the camera and do things like that without ever having done one of these before. So I'd say that's not too bad. Now I do have some experience with 3D printers, so got to factor that in. This is not something you want to do sort of first time out. I did have some early issues with some Z-banding, which is just sort of weird artifacts at a regular pattern in the Z-axis on the prints, which I'll get into later, kind of what was going on with that. But that was fixed. Formbot was great about it. Their support was fine. They sent me a new part, which fixed everything I had. The dual color calibration, which I'll talk about a little bit more of why I kind of don't use dual color that much on it, but this is obviously fully capable of it because of the dual independent extrusion. That was relatively fine as long as you understand G-code commands. So if you're looking to use something like this with the dual color, definitely kind of take your time with those steps in the documentation. They don't make a whole lot of sense looking at them if you don't understand at all what G-code is. I will say that out of the box, the jerk settings, or it's kind of related to acceleration, but it's how fast it will accelerate, are a little bit too high. Having a higher jerk setting on the X and Y axis will allow you to print a little bit faster, but I value the quality over the print speed a little bit more, so I had to dial that back to kind of get everything to come out nicely with nice sharp corners and everything like that. The stock aluminum bed on this is generally fine. I don't like the fact that there's nothing removable on it, because if something gets stuck on your print bed, you're gonna have to just get it off before you can go on with anything else, and that may or may not break the print. I didn't have anything that really stuck too badly. Actually, I had issues getting stuff to stick at all at first because it's just stock aluminum. But cleaning it really well with isopropyl alcohol, and I mean, like, the first time out of the box, I wiped it down with a new solution of isopropyl alcohol like 3 or 4 times until a paper towel came back completely clean, to kind of get all of the the grease and whatever that was on there off, and then a liberal coating of PVA glue, or I also had gotten a sample of that Magic glue, which is basically just specially formatted PVA. Worked really well, and then once it cooled down, popped right off. However, I'm using a completely different build plate system at this point that fits on top of the one that's here. I'll go into that a little bit more when I talk about my mods. Now, I will say I wanted to get some more like really long prints running on this, a day or more, before I did a review on it. And I have done some relatively long ones, but nothing more than a full day. I haven't really had anything that I needed to print that was going to take that long yet. Now, a printer like this, you know, the upside is it prints huge things. The downside is that, you know, you've got that square cube law, where if you increase the size of something by 200%, you've increased the volume of it 8 times. So, you know, you just double your model, well, it's not going to take twice as long, it's going to take 8 times as long to print, which obviously kind of adds some complications into that. And this thing will print objects that are large enough that it will take not just days, but weeks, if not longer, to print the whole thing. So I can't really speak to yet if this, you know, is going to hold up for a print that long. I believe it should. I've had it go through a 20-hour plus print with flying colors, with no problems. The print looks great. So, you know, that should be fine. But with a printer like this, you know, I really was more looking at it for being able to do objects that were relatively wide or objects that were relatively tall, but not necessarily both. I just wanted the flexibility to do whatever I wanted within the build volume here. Printing something that fills up the entire thing just kind of gets a little silly at some point. I probably in the future will have something that has, you know, utilizes that ability, but right now I haven't, and I wasn't going to print something off just for the sake of printing it off. I did do something that's relatively large, but I'll show it when I show off all the prints and the quality of those. But it's still not like the full thing. It was still only about a 14-hour print, despite the size of it. And I can't say enough, this is not a beginner printer. Do not buy this if it is your first 3D printer. Start somewhere else. Start smaller. Start with something that is a little bit more of a nice out-of-the-box experience. The learning curve on this is not terrible, but also I already knew how to use a 3D printer. I had already disassembled and rebuilt my previous one many, many times, so I knew how everything should function. I dove right into this with modifications nearly day one, with what I wanted to do, with what I wanted to change it. So it's a tinkerer's printer. It's the kind of thing where you want a good base platform to build onto. And everyone I see in the Facebook group that uses it, for the most part, is adding onto it and adding, you know, flexible material capability or doing extruder modifications or a different heated bed or, you know, whatever. They're adding onto it. It's a great platform to start because it's a very basic thing. There's not a lot to it. It's not enclosed. It's not a big plastic shell. So from that standpoint, it's actually nice if you want to be able to just kind of have at it and go. I mean, you could build a printer like this from scratch if you wanted to design it, but this gets you 99% of the way there, and then you can start doing your modifications on it. But if the thought of having to modify G-code or completely disassemble the extruder mechanism and rebuild it from scratch makes you cringe, this is not the kind of thing that you want to go after. And I'll go into that a little bit more once I show off some of the modifications and talk about the print quality and all of that. So now, let's show you some of the mods that I've done on this. Alright, so now that we can get a closer view of this thing, so the first thing that's probably going to stand out to everyone is I've got this orange cover over the control box on the left-hand side here. Now, the reason for this is actually not because I didn't like the cover, it's because I didn't like the fan. This originally had two, I think it was 40 or 50 millimeter fans in it, and I believe they probably were somewhere around 65 decibels just at idle, and those were there to basically cool the board drivers that are inside this control board. And it was just crazy loud. Even inside this closet, it made a ton of noise. It was really annoying. I had to, like, you know, turn the TV way up when I was watching TV in my office. So what I decided to do was replace it with this 80 millimeter Noctua fan. It's a probably about $10 fan I got on Amazon. There'll be a link in the description, of course, as well as to the designs for this case cover. And the entire reason for this case cover was just to make more space for the larger fan because it's a bit thicker than the originals. But this one runs at, I think, 17 decibels as opposed to 65. It's whisper quiet. You can barely hear it. It's actually now quieter than the cooling fans on the extruders. So that's much, much better. And then, you know, this obviously breaks out to where the SD card and the USB cable come in. It goes right over where the original cover did. The only difference is that these screws are different. They just had to be a little bit longer. They're M3 20 millimeter long screws. no big deal. So that was actually one of my earlier prints on this. So another thing you'll see up here is the spool holders. So the default spool holders that come with this bolt on just sort of in the same place, but they're ball bearing rollers. And I hate them because the spools just sort of rest right on top of them, you know, just sort of sitting right on top like there, if there's the bearing rollers underneath them. But there's nothing that actually provides any sort of lateral support. And I had, while printing these, I literally had to monitor the print because the spool kept trying to fall off of the original spool holders. So I printed these. These I did not design. They came from one of the users on the Facebook group. Again, I'll provide a link. And these were just a sort of a quick and easy print. They bolt right into the top of the 4040 extrusion with a little T-nut, and they've worked great. I mean, they're not, you know, obviously they're 3D printed, so they're not like super smooth or you know, bearings or anything up there, but I've had no problems with this pulling on these and them just spinning right along. Actually, as you notice here, it kind of unspooled a little bit too much, but those have worked great. And let's see what else we got. So one other major thing you'll notice compared to the pictures online is that, as you can see, my extruders are kind of all Frankenstein. And that's because the default setup on these has a single fan. And that one fan is trying to cool the heat sink that's behind here, but it's also providing the part cooling. And the way that they tell you to do that, although this is, again, not in the instructions, but I found that online, was they have a 3D printed fan shroud that basically they say, well, if you run the fan at over 50% speed, it's then providing cooling, but below that, I guess they think that the speed of the air is not enough to go through, you know, through down to the part. But it's not great. It works, but I don't like the fact that in the slicer settings I have to go, okay, I want the fan to be turned on, so it needs to be over 50%. That it's just silly. So the great guy on the Facebook group, Colin Casey, had come up with how to do this dual fan mod. And the parts were sort of originally inspired by him, but I actually redesigned these because he has an earlier version of this 2 Plus printer, and mine, they didn't quite fit right, so I ended up redesigning them, and these fit a little bit better. But what happens here is that if you look, so the fan that's plugged into this top connection, that fan is actually controlled by G-code, so you can specify the speed in your slicer, you know, whatever layer you want or whatever, and that will control now this fan down in the front. But the fan that's right here is always on, and that's wired into this other connection that comes over here, and then you can't see it, but it's soldered under the board. And although actually I have one of the other control boards here, so this is for the right extruder, and as you can see on the back, this is just soldered in. It's actually soldered to the positive rail of the heater cartridge, and then the basically grounding terminal for the and then to basically the grounding terminal for this VGA cable that comes in here. And yes, as far as any of us can tell, this is just legit a VGA cable. That's all the connector is. There's nothing more complicated than that. So I think the reason why the wiring on this works is none of these components actually really have they don't share a ground per se, because nothing actually normally is hooked up to the shielding on this VGA connector, but it is actually grounded to the case, so that did work for the fan that we wanted to always be on. But the heater cartridge, the 5-volt rail is always energized, and then they're clearly doing a low side like MOSFET control on that to turn that on and off. So that's why that works at all. Now I've got this one, and you know, it's all, you know, soldered on there. I've got some hot glue. Now I'm kind of a neat freak when it comes to my electronics. I didn't like that, so I instead designed these. Now this is the reason this is sitting here is I've installed this on the right extruder, but I haven't bothered to install it on the left extruder yet. So this is for the left, which is why it has, unlike this one, why it has these other two connectors. Those are for the BL Touch probe, which I'll talk about in a second, and is actually really great. But as you'll notice, this one has 3 connectors here. So it's for the always on fan, for the G-code controlled fan, and for the thermistor, so that's the temperature sensing. And I put on just a screw terminal instead of this connector that they had on here, mostly because these were kind of impossible to find. They're not like really a standard, it's just something that I guess Formbot decided to use. And you know, these screw terminals are easier to find, plus it makes it a little bit easier to use whatever heater cartridge type I want. So with this, as I can move over here, so now you'll see this is the right hand extruder. So now you can see I've got, instead of just a sort of janky soldered on wire, I've got 3 proper, I think these are JST-XH connectors, which are soldered onto the board. Just move that out of the way. And those are all connected in there, and then I have full control over everything. So fan in the front is G-code controlled, fan in the back is just always on. And design those all in KiCad. Of course, you know, those will be all open source and whatnot. All the files to those will be provided. So yeah, that was actually my last mod, which tells my last because I haven't installed this one yet. It's been working. I just, you know, it's not a problem. These wires are fine. It's just more, it inherently bugs me because of me and the way I think. So I will do that at some point. You know, I've tested the circuit on this. This should all work, but the right-hand one does work perfectly fine. I've done, I don't know, probably 100 hours worth of printing on that, which brings me to one of my other mods with this. Now, this is not something that I can show specifically here without fully disassembling everything, but as you can see, this has got 2 fully independent extruders, which is great. Now, a lot of people would use that for dual color, but honestly, most of what I do is sort of structural and functional. I don't, you know, a lot of people when they have 3D printers, they print a lot of what I jokingly just call tchotchkes, like just little silly things to put on their desk. I have enough stuff on my desk, I don't need more stuff. So I like to design my own thing, you know, cases for LED displays that I make or whatever like that. And as I've probably noted already, I'm really lazy and I don't like to, you know, I don't like to have to take a lot of time to switch things out. So they have these supposedly quick swap nozzles that, because they were like stupid cheap, I mean basically like $1, not even $1.50 a piece, I bought like 3 or 4 sets when I bought the printer. Now this is the 0.4 millimeter nozzle that I took out of the right hand extruder. And the only thing that makes these quick swap is that you don't have to physically unscrew the nozzle itself, which then sometimes means that then the heat break up here gets a little bit you know, loose, and you got to deal with all that. So how to actually swap one of these, and I'll probably do a video on one of these later when I rebuild one of my extruders, is you have to take off all of the fans, which this would obviously be different if you didn't have my mod, but it's, you take off that original aluminum red cover and the fan comes with it, you unplug it. And then there's 2 set screws that hold this in, and you undo those, and then this will drop out, except for that it actually won't until you completely undo this screw and this set screw, which loosens the heater cartridge and the thermistor. Then you can pull those out. Then this will probably come right out, but that's also assuming that you can get to this screw and set screw without taking the entire extruder off, which is not too bad. I've done it a bunch of times at this point, but still, that's what you probably are going to have to do. Then you take another one of these of probably a different size or whatever, and you insert the heater cartridge, you insert the thermistor, you retighten the screw and the set screw, and then you put that back into the heatsink block and retighten those 2 set screws you used to remove this, and then you put everything back onto it, you know, all the fan shrouds and all that stuff and all the connections. And then you're ready to print, right? No, you're not, because now this has not been put in with, you know, sub-10th of a millimeter precision that you need when you calibrated the Z offset. So now you need to, if you did it in the left-hand one over here, because this has got the BL Touch probe, you need to redo the Z offset calibration, which is not too hard. You drop it down, you put a piece of paper under it, you keep lowering it down you know, towards the bed down here, and then you make sure that you get it the right distance. It's all in the instructions, and those instructions are actually pretty good. And then you can redo that. However, the right-hand one is assuming, because it doesn't have a probe, it assumes that it's the same offset as this one. Then you got to calibrate the right-hand one to the left one, which is another whole thing. Basically, I kind of bring them out here after I get the left-hand one calibrated, and then I will stick a piece of paper under both of them, loosen the set screws on both of them, and so they drop to sit on top of the paper, and then I'll tighten them back up, and then theoretically they should be the same, but I usually have to do that 2 or 3 times. That's kind of the one downside to the independent dual extrusion, is that because they don't have their own probes, they don't know what their offset is. Like, if I was to do this, you know, to contribute to the design of this, I probably would put a probe on both, and then have, before you do a print, probe the left, come out, probe the right, and then in software just do an offset. So basically I go, okay, now I know that the, you know, whatever, the right-hand side is 0.002 millimeters off from the left, so you just adjust that. I'm probably oversimplifying. I've never built one of these myself, but it's just sort of a thought. It is possible to get them all, you know, calibrated together, but it's, you know, they say, oh, you can swap one of these out in a minute. Well, yes, but then there's the 15 to 20 minutes of recalibration of your printer. So instead, because I'm not really big into multicolored prints, this extruder on the left is a 0.4 millimeter nozzle, which is kind of your standard. I actually have down to, I think, a 0.2 or 0.25, so I can do really, really fine prints, but 0.4 is fine. That's why they put it on most printers. It's good for relatively high detail stuff. You can get away with really nice 0.1 or even 0.05 millimeter layer heights if you want to be crazy. But this printer, as I've noted, is enormous. So you can get the whole thing in there. You know, this is 500 millimeters high and 400 by 400 millimeter, build plate. So sometimes I just want to do things fast. So this extruder has a 0.8 millimeter nozzle. Now I do actually have on hand a 1 millimeter nozzle, which is still not quite as big as the, I think it's a 1.2 that you can get with the new Lulz bots. But the real reason for that is, as you note on here, this is sort of your standard heat block. It's only a 40 watt heater. And this just really doesn't have enough heat carrying capacity to melt enough plastic to print at any decent speed while going through a 1 millimeter or even higher nozzle. It's just sort of a little bit crazy. So instead, you know, I did the 0.8 on this, which is pretty good, but even though it's double the, you know, the nozzle diameter, it's 4 times the amount of plastic for every millimeter, you know, every distance of filament that you push through it. So it's a lot. I have to run it at about 25 degrees C hotter and run a little bit slower. So on the 0.4, I can print at 70 to 80 millimeters per second, and on the 0.8, I can usually print at 40 or 50, maybe 60 if I really want to push it. If I really wanted to do more stuff with really big bore nozzles, I would need something like the E3D Volcano, which instead of, you know, this little thing has a heat block that's probably twice or even 3 times that size, and a much bigger or much, you know, beefier heater cartridge, which can provide a lot more heat, can heat everything through a lot faster as you push it through. However, you know, doing like a vase mode style print on a 0.8 is fantastic. I can barrel through it. I did a print just the other day that actually wasn't vase mode, but it was mostly hollow. I'll show that in a second. And, you know, it only took 14 hours, whereas with the 0.4 millimeter nozzle, it would have taken somewhere in the order of 40. So having that capability is, in fact, quite great. That's all with the nozzles. You know, I've also added, as you can kind of see down here, I did this when I rebuilt this whole extruder. I added one of these E3D style, I guess they call them silicone socks. That basically just really stabilizes the temperatures on it. It keeps them warm. I mean, it's what socks do. And yeah, these heat blocks, even though they're not E3D compatible, or like not all of it, I think that the nozzles technically are, but the E3D nozzles are slightly shorter, so you'd have to recalibrate the offsets and recalibrate the BL Touch probe. But the block itself, the aluminum, you know, block, is the exact same layout and size. So on that note, though, I mean, You can kind of see behind there that little piece of the circuit board with the wires coming off of it. Let's see if I can get it better. So yeah, that little pin coming up on the left-hand side, that is the BL Touch probe. I honestly would be shocked if it is a legit, OEM part from the company that makes that officially, because this is a printer from China and they probably got a knockoff, which it works, so I'm okay with it for now. But yeah, that probe, it does a couple of things. One, you can have it probe the entire build plate. It does 255 points when you get started up, so that it can do what's called tramming, which means that if your build plate is either slightly warped or not 100% level, it actually adjusts for that when printing with slight, Z variations as it prints. You can actually see the ball screws in here moving slightly just to make up for any imperfections. In general, though, I level my platform. The build plate is pretty darn flat, so I don't really have a huge issue with that. So another thing that kind of has to do with the extruders, which are not going to show up great because they're black, are these. So these are basically the drip or ooze buckets, which is because when these are not printing, if you're printing in full like dual extruder where it was going back and forth between the colors, it would sit over here, and this makes it so that anything that's kind of dripping out of the nozzle while it's still heated, because it's going to do that because there's some pressure on it, would drip into that, and then it would get wiped off as it comes out to go print. The problem I had with it was right here, the thing that wipes it off, on the default buckets that come from Formbot are these like wire brass things, and those would actually get really clogged up. And I actually had one time where on the right-hand extruder, it basically ripped that whole brush off because it had been sitting there and plastic had been oozing out, and it basically congealed and got stuck. So that was no good. So I modified these and actually completely kind of reverse engineered the design and redesigned these from scratch so that they fit on where the stock ones were. But instead of a brass brush, I'm using this literally silicone squeegee blade. Bought them off of Amazon. Again, I'll provide links for all of this, but I just cut it to length. It fits right in there, and it kind of slides out the back. But so the extruder nozzle wipes back and forth over that, and it's been great. I've not really had a problem. Nothing sticks to it because it's silicone. It's rated for 600C or something like that. So that's been fine. So the other last thing that I want to talk about in terms of, I guess, modifications, if you can call it that, on this, is the build plate itself. Now I'll move these off to the side. As you can see, I've got this Gecko Tech surface on here, but that's not actually all of it. Here, I'll even move this out. So the printer's off, so I can kind of move everything around willy-nilly as I want to. But the cool thing is, this comes right off. So, and as you can see here, it says BuildTech FlexPlate. So this is a system that you can get from BuildTech. Now, I know my print surface is not actually BuildTech, but I'll get into that in a second. It is a magnetic plate that actually adheres to your stock plate. So you can still see the aluminum plate underneath this, which printed fine for the most part. At least with PLA, I had to print a little bit hotter than I was used to, and I had to make sure I put down a good amount of PVA glue, and then it would stick. And then once the aluminum cooled down, after the heated build plate would turn off, the prints would usually pop right off. But there was nothing that you could actually physically remove from the printer. With my Replicator 2, I was used to that at the very least I could remove the acrylic build plate, and I used to just like throw it in the freezer, which would help the parts pop off. But instead, on this one, you can't do that. I mean, this build plate, not only is it screwed down, but the silicone heating pad is permanently bonded, or at least yours makes no difference, permanently bonded to the bottom of this plate. So you can't take that off, and you wouldn't want to. So instead, I've got this, which is a little, probably about 3mm thick pad. It's made of some sort of foam, I guess. It's kind of hard to say. I mean, it's a little bit harder than that. On the top, it's some sort of like thick vinyl type thing. And you can't see it here. You could on the back of it, but there's a grid of probably 20 by 20 high temperature neodymium magnets. So what that allows is something like this. So this is that Gecko-Tech plate that I had, but as you can see from the back of this, this is just a sheet of galvanized spring steel. So that, when I lay that down, you can kind of see it, it's got some force that pulls that down on there. So obviously this is not lined up, but this is not going anywhere. I've never had any problems with this slipping or anything like that, but when I'm done with a print, I can literally just lift it up. You kind of just grab it from a corner, it comes right off, and now I've got a plate that is flexible. So when I have large prints, I pull them off, I flex the plate, and the print generally just pops right off. Now, I will say, you do still want to let it cool down a little bit, but as long as this plate's not super hot to touch, like if I'm doing PLA, it's 60 degrees centigrade, not a big deal, I can touch that barehanded. I'll pull the plate off and I'll just set it off to the side. And that'll cool off pretty quick because there's not a lot of thermal mass right here. And usually within 10 minutes, you can just, flex the whole plate, the print pops right off. I've not really had any huge problems with it. And because this is removable, I can print on any surface I want. So this is the actual BuildTak surface that came with the printer, or came with the flex plate itself. So this one's a little bit shinier. You can kind of see that says flex plate on there. This is the stock spring steel plate that came with it. And then I put the BuildTak surface on here. And this is, well, it's funny, it doesn't really stick at the moment because there's the other plate on there. The magnetism is not getting through, but I can, swap off to another print real quick with this. I have another spring steel plate that's covered in Gecko-Tech as well. I don't have any more BuildTak, but I can swap off the Gecko-Tech, put in a new one, and go back to printing with basically no downtime. Or just if things stick better. Because, like, for example, I found, and unfortunately it's really kind of hard to see with this, for example, I found that Gecko-Tech works fantastic for PLA, it was working for PETG and ABS, but then I tried to print some Ninja-Tech Cheetah, and that stuff, I mean, it's kind of weird printing a flexible material on a flex plate. It doesn't give you the advantage, but I was just using it for the basic service. But that stuff will rip up this Gecko-Tech. It sticks way too well, and it's impossible to see on camera really here because it's all just sort of white on white, but there's little pocks and dimples in this where it ripped up some pieces of the actual build surface. It's not unusable because obviously this is a giant plate, but there are things like that didn't work. However, the BuildTak back here worked fine. So now when I want to do the Ninja-Tech stuff, I swap it out for the BuildTak, not a problem. I also have just a bare metal plate that if for whatever reason I really want to kind of go old school and print on just like blue painter's tape or with some PVA glue, I can do that. And the reason for that is that, as I noted, this plate looks a little bit different. This one was bought from a company called onlinemetals.com. Now the whole flex plate system is normally, I don't know, somewhere just shy of $200 for the whole thing for this printer. Obviously it's much cheaper if you have a smaller printer, but it's 400 by 400 millimeters, so it's a much more expensive system. And that comes with the magnetic base and the metal sheet that came with this one and the BuildTak surface, but that was it. If you wanted to buy another metal plate, you could, but they were like $50 or $60 a piece. Online Metals, however, I bought 5 of these for, I think, $80. They work great. I've not had any issue with them. They're a little bit thicker, maybe a little bit less springy, but it's really been no problem. So now I've got a bunch of these I can swap out just whenever I need to. You'll also notice I've got a camera set up over here. This is for monitoring it remotely because I actually will keep these closet doors closed to kind of keep everything nice and hot in here, and I don't want to have to open it all the time. And that's connected over to this, which is just a Raspberry Pi 3 running the latest Octoprint. That works great. I originally tried printing like directly from Simplify 3D, or I would sometimes print from an SD card, but honestly this is just much more convenient. I can monitor it remotely, especially a giant printer like this is going to do massively long prints, so I can go to work, and still check on it on my phone or from my computer or whatever. So that's definitely, I would say, a must-have for any printer that's of this size, is to print with Octoprint. It prints no problem. I can do time lapses with the camera. Everything works great. And the only reason that I have like a standard webcam as opposed to like a Raspberry Pi camera is mostly the quality's better, and also the stock Raspberry Pi cameras are not USB, so they have this weird like thin ribbon cable, and having a cable that was thinner like this was just easier to run it. So that's kind of why I went with that. I also, let me move this, not that you can see it. So in terms of other kind of modifications on here, this motor has actually been swapped out. The stock one is only 1 amp, and this whole plate is a lot of mass, especially as you throw plastic on here. I mean, it's basically the same motor as what's being used for the Z-axis, rods on both sides. But those are only having to lift this X-axis gantry, which doesn't really weigh a lot, and it's constant. This, however, I found that I got a lot less sort of acceleration artifacts on the print and not Z-banding, but I think they'll call it like salmon skin, like banding on the prints when I swapped out this motor for a 2 amp one, which again, I'll have a link for on Amazon. It's a relatively easy swap out. Just have to kind of run the cables to the back. So that's got a lot more power. The drivers on the 2 Plus are already in the the control box, are already capable of doing it. They just put a smaller motor in for whatever reason. So with that, it's been a lot better. It can accelerate quicker, it can slow down quicker, so that's definitely been a good advantage. So one of the other problems that I did have with this at some point early on, there's honestly one of the few, just kind of annoying to work through, was that prints should look nice and smooth, like this Benchy here, but I ended up coming out with one. This is really where I first noticed it. That looked like this, and as you can see, this is not like I did something weird with the settings, but there's all this stripiness along the Z, and that turned out to be that basically either there was something wrong from manufacturing, or something got into this bearing, this Z bearing down here. A lot of 3D printers will use just a threaded rod, and basically, effectively what they're doing is they're mounting, whatever part of that axis is to really not much more than a nut, something that's got, female threading in it, and then that just rides up and down along the threaded rod. The problem with that is that you have to considerably lubricate that all the time, and there's a lot of friction on there. Whereas with this, that little thing below the mount is what's called a ball screw bearing. So kind of look at these, they're not normal threads, they're sort of concave, and it's actually ball bearings that run around there. So it's supposed to run a lot smoother. But all we can think of is that something, either the actual ball screw itself was this part right here was actually warped, which is unlikely, or somehow something was wrong with the actual bearing. And after 20 or 30 hours worth of printing, this sort of manifested itself, where basically what would happen was it was causing some sort of tension on that ball screw so that it wasn't riding right. And if you look at these, again, it's kind of hard to see on camera, but this striation is exactly the same sort of offset as the threads on the ball screw. So what was happening was, as it was coming around every single, one full rotation, it was causing this offset. Not entirely sure if it was, just not moving that one side all the way up as much as it should, and then it was catching up. We're not sure. I went through sort of a lot of alignment things with it that did help. In the end, though, I will admit that I did have to get Formbot to send me a full new ball screw assembly, which included the bearing and everything. It wasn't super bad to take out, but it took me a couple hours, and then I had to get it realigned up here. These are not the greatest design for brackets. They're basically just laser cut acrylic with some bearings in there. But once I did that, it really wasn't bad. One of the things you'll see on here that's a little bit different is you see some screws with some springs. That I did in my initial attempts to kind of try to fix the Z-banding issue. which I had going on for a couple of weeks until I got the new ball screws from Formbot. But those were actually suggested by someone on the Facebook group, and they do actually cut down on a lot of it, because a lot of printers like this would actually design it so that the axis that this is on is not super tightly locked to those ball screws, because if there's any variations and if it's not 100% perfectly aligned, you'll get some wobble, which is going to cause, you know, weird artifacts in your print. So with these, it allows the whole thing to ride kind of loose from what it is. It can kind of move side to side. It also prevents it so that if for some reason I do something stupid and I bury the extruder into the plate, it's not going to really cause any huge problem or bend anything. And I have done that accidentally, because I've been, you know, modifying it. I don't have a sensor set hooked up or something like that, and I have to kill the power. So that does help with that. That's really the most major thing I've had that was, you know, any real problem. But now all the prints, this is actually printed after this Z-banded one, and now everything prints nice and smooth. All right, so just going to show off some of the prints that I've done on this. Now, a lot of the prints that I've done are actually on the printer, and you'll have seen those in the mods, like the case cover, the control box case cover, and the spool holders, and all of the fan shrouds, and all of that. So those are all actually printed on the Formbot itself. So just sort of as a quick start, I mean, you'll see here, like, these are sort of standard calibration cubes that I print basically for every new material, or when I do a modification of the printer itself, just to make sure that everything's still dialed in where I want it to be. This just makes sure that there's no, you know, blobbing on the corners, and that the lines look good and there's no banding. So like, this is a PETG, so this was basically, I had never used PETG and wanted to give that a shot, so tried this out. These are both PLA. These are some of the really early prints I did on this after kind of getting everything dialed in. So yeah, those are basic. You can see everything's nice and super smooth, and yeah, they came out good. So, you know, even in terms of accuracy, you can see on this one's supposed to be 20 millimeters. It's about 0.1 off. Well, yeah, that one's actually dead on to 20. And let's see the height on this, dead on to 20. I think that this is, I had modified the x-axis a little bit. So yeah, you can see everything, you know, works pretty well. Everything's about what you would expect it to be. As I'll have noted, there was some Z-banding issues. This is really the first thing that I started seeing an issue with, and you can see, you know, there's just this sort of banding up in there, and that was caused by a bad ball screw or something wrong with the ball screw bearing. So that, fortunately, Formbot very quickly replaced, and that was no big deal. I got back up and running in no time. You know, obviously it should really look more like this one, this nice little benchy where everything's nice and smooth and neat, and comes out nicely. So I think this one was printed at 0.2 millimeters. This is obviously a little bit larger than the stock model size. I could obviously go much larger, but you know, these take a long time. And I'll get into some larger print in a second. So another great one, which you may have seen in another video, this is the Adafruit Pie Girl that I did. This was printed in the same PETG as this. So yeah, this came out great. Any kind of striations that you see on this is really just because this is clear. So these are all the layer lines as it was printed. I could have mitigated that a little bit with maybe some of the slicer settings, but in general, with PETG, it's a little bit clear, so you're going to kind of get some artifacts like that. But I'm super pleased with how this came out. This is a snap fit case. Everything just came together really nicely with it. You know, so there's no screws holding this together. It just pops together. You can pop it apart with like a little guitar pick or something like that, and not have a huge problem. Another thing that I tried early on to do something a little bit taller, so this is a model rocket. I did a lot of model rocketry when I was in college, and I can't even imagine what I would have done if I had a 3D printer back at the time, because I didn't even use kits. I just made them out of whatever I could find. But with this, I can design it you know, it's no problem. As you can see, there's a little bit of a dimple in the middle of there, and the rocket engine just slides up the back of there and then is held in by that. So when the ejection charge goes off, the rocket should shoot out. As you can see, you know, there's no top on this, and that's because another one, that one was slightly wrong size. My bad, not the printer's. So this is a full thing. This whole thing's, I think, about 350 millimeters tall. I've also printed another one, which I broke, so I don't have it here, that I printed just all one piece. I realized I should put some sort of break in this so that I can break it apart and have it come down nicely with a streamer. Otherwise, I've just got a very pointy missile coming back to the ground. But yeah, I mean, this will print straight up on this printer, no problem. You know, I don't know of really any other printer that has the capability of doing that, where I can print something like this tall and I have no problem. Now, this one was actually printed with the 0.8 millimeter nozzle that I've mentioned. So this is vase mode. This is, you know, just one continuous spiral. You can see from the bottom of that, there's, you know, this is just one outline. It's kind of great to be able to do that. I had to design it with that in mind because I designed the outer diameter of this, and then the rocket engine fits in here. So the outer diameter of this is just the outer diameter of the rocket engine plus 1.6, so 0.8 for each side, and then it works well. And it's a little bit flex fit. It comes apart like that. But yeah, these have worked out really well. I haven't gotten a chance to really fly these much, but I think that this will be some good fun in the future. So another print. This is also in vase mode, but it's because it's a vase, or actually it's going to be a lampshade. There's some holes down in the bottom. That's for mating to an LED panel that I'm going to stick in the bottom there. I did this this was the first thing that I did with the 0.8 millimeter nozzle. All the rest of this, except for the rocket, was with the 0.4, and I did this really as a test. This was not one I found online. It was just one I designed in Fusion 360 real quick, and I was able to kind of, you know, knock this out. So this was initially all solid, except for I'd put holes, you know, down the middle in here. That was a little bit weird doing a vase mode, but having holes in the bottom. Maybe sometime we'll do a video on how to do that. But yeah, this is not bad. So this is one shell. It's just a 0.8 millimeter. I could have done this as 0.4. It would have worked. Those are really, really thin. I mean, 0.4 is next to nothing, but this is really sturdy and really kind of nice and thick. It's gonna hold up. So I'll print a base for this, and then, you know, connect this to the LED panel, and this should make a nice little lamp. I couldn't bring myself to make an actual vase because I don't need a vase at all. But yeah, the other last large thing I did. So this turned out so good. It's a low poly penguin. I did, when I was going to look for something really big and kind of impressive to print, I really was looking for something that had some more detail. But then I kept seeing this model and I just wanted it. I don't normally just want random things that are useless. You know, I work on Linux software at Red Hat, so, you know, the Tux Penguin's kind of always part of my daily life. So I don't know. This seemed like something that would be good at work. I mean, I can barely get this thing in frame. So this whole thing is 440 millimeters tall. So not quite the full build height, but pretty darn close. I didn't want to make it too much bigger. And then, you know, total width side to side is a little over 200 millimeters. So you know, even width-wise, this would not fit on your standard like Prusa style printer, because a lot of them now, I've noticed, they kind of have the 200 millimeter cube is sort of the standard size. This, I mean, even aside from height, but you wouldn't even be able to fit the width of this on one of those, or at least it'd be really close. This is not vase mode. It's not spiral, and that's purely because of this down on the bottom. So as you notice, there's no continuous perimeter path between his feet and his tail. But it was printed with the 0.8 millimeter nozzle, just because I was lazy and I didn't want to wait real long, just with zero infill. So this was 2 shells at 0.8 millimeters. So this is actually 1.6 thick. It's really sturdy. I mean, you can, if you try to squeeze this, there's no give, or very little. This is not going to break anytime soon. So it was printed, yeah, with no infill. This is completely hollow. And it came out great. I mean, the sides are super smooth. Maybe little tiny striations you can kind of see, but it feels perfectly smooth. I'm really, really happy with this. And this was, I didn't like, spend a bunch of time getting this particular filament dialed in or anything like that. This is just straight off the printer. The reason why I did this with the 0.8 as opposed to the 0.4 is just time. And that's, as I've noted, I don't do dual color really much. I mean, I could on this printer if I swap the nozzles back out, but I don't really have a huge need for it. What I do have a huge need for is being able to swap to a different nozzle size without having to go through a bunch of recalibration and stuff. So, left hand is 0.4, right hand is 0.8. I've got a special Simplify 3D profile set up where I can just switch over to the 0.8 when I want to do something quick. And this would have been close to 40 hours on a 0.4 with zero infill. And this was maybe 14, 13, somewhere around there, printed on the 0.8. And it's just, because I would have had to have done 4 shells to get the same thickness on the 0.4. So there's just that much more time going around. There are a couple of things that ended up being a little bit of a problem on this. If you can kind of see down, let's see if I can get that to show up right. Well, down in here, it's a very, very steep overhang. I'm actually kind of surprised that printed at all. And then I did notice there's a couple of little weird things on his head. And again, that's really just because it's a super steep overhang. If I had been smart about this, what I would have done was, in Simplify 3D, you can do multiple processes, which allow you to specify differing infills. So if I was going to do this again, I would do one process for like here down, and I would do infill in there so that his feet had some infill, so it was a little bit better. And maybe even do slightly lower layer heights, because this thing was printed at 0.4. I mean, so these are really thick lines, which I'm kind of amazed it came out this nicely. And then I would have done basically from the feet up, just empty, because there's nothing really going to get in the way. And then when you get to the head around here, I would have started doing infill again. Now, that initial infill is just going to kind of be hanging out there. But as you get more and more levels, it's supporting itself more and more, then it would have been fine. So I think that some of this just kind of fell down a little bit, which is okay. I mean, the rest of it looks really good. And yes, I did put googly eyes on him. So yeah, so that's the prints, and yeah, I'm super pleased with it. I mean, as I'll have noted, the printer is a little bit of a tinkerer's printer. You got to be willing to dial it in and get the profiles right, because it doesn't come from the factory. It comes from the factory with profiles, but not with like super dialed in for that specific filament that you use. I think like the Lulz bots, they come with Cure, and it has like profiles for Engine and Polymaker and like all these materials that they've already tried, whereas the Formbot came with a roll of PLA, which is completely no brand, that I literally threw out because it was just total junk. So you got to be able to dial in, but once you do, man, this is great, and this can print like this all day long. So yeah, that's it for the 3D prints. Now back to the other stuff. I kind of want to get out of the way first with this. That I've had a lot of people say, "Oh, is this the best printer you can get that's in this size or this price range or whatever?" And I would say in this price range, it depends. The 3D printing world is one that you have a lot of variability in terms of capabilities and physical size, printing dimensions and price for the printer. I very specifically wanted a printer with a giant build volume. Not necessarily that I'm going to print something that's that full size. As a side note, I actually did the math and ran it through Simplify 3D. If I printed the full volume of this solid, it would take 98 days and weigh 250 pounds. So I mean, that's what this is capable of. It's 80 liters. It's massive. I'm not necessarily going to use all of that, but I've printed some things that are very wide and not necessarily so tall, and I've printed things that take up the entire build height. And it's fantastic to have that flexibility, and I don't really have to think about, okay, how do I slice this to fit it on my printer? That's what I'm going for with this. I am inherently lazy. I want something that's just going to get it done and, get it done easily without me having to do a bunch of stuff. Now, this was cheaper than the MakerBot Replicator 2 that we had previous, yet it has dual extrusion, it's dual independent extrusion, it has literally 12 times the build volume, which is just absolutely insane. It's got a heated build platform, but you may not necessarily need that. A lot of people would be fine with a smaller printer like the Prusa Mark II, Mark III, whatever, which is less than half the price of this. But I will admit, after messing with this for the last few months, is probably going to be a quicker and better out-of-box experience for someone that's not used to 3D printing. So this is a great printer. I absolutely love it. I'll go through some of the prints that I've done. You'll be able to see the print quality. They're wonderful. I've had some failures, but a lot of it came out really great, and it's a fantastic printer. However, it is not a first-time user's printer. As you saw with all the modifications that I've done, I spent a lot of time working through what I thought was good, what I thought was bad. Now, I have an engineering background. This is the kind of thing that I not only can do, but love to do. I like dropping into my CAD tools and designing a new part for something and making it in at least what I think is better. That's not to say that this needed any of those modifications. It worked great out of the box. I printed a bunch of great tests. The quality was good. There was no artifacting. Everything worked good. I'm doing more on this just because that's me. I wanted to add more to it. But also, it's an older style Marlin LCD, and by Marlin I just mean like the readout is from the Marlin firmware, so it's very basic. It's from a Chinese company, so the documentation is a little bit sketchy. Now, fortunately, as I think I mentioned previously, there's a wonderful Facebook group that I've gotten a ton of support through them, and it's a great community. And they've provided a lot of documentation sources and hacks and mods, and I've contributed back to that, which is great to be able to be part of. But still, you look at the original docs. If you didn't have that, it'd be very hard to really get fully up and running on this, because there's some things that it very much assumes that you know what you're doing with a 3D printer, and that for example, the documentation will tell you to modify G-code file to reset the second extruder XY offset. Well, a newcomer would not know probably anything about G-code or what that means, or it's not going to make any sense. For me, I was used to it. I could drop right in, say, okay, cool, edit this, and send it. And actually even go beyond that and say, I don't need to save this into a file. I can just open up the Octoprint G-code terminal and paste in the command, and I'm good to go. So, yes, this is a wonderful printer. Yes, I love it. I do recommend it for someone who is already into 3D printing, has had at least one, if not maybe a couple, and is looking for something that is massive, can do dual extrusion if they want it. Although, as I noted previously in the video, I do that a little bit differently. I'm not using dual color so much, and can do it at a decently low cost. You're going to get great prints with this. It's wonderful. It's just not first time printer wonderful. I think some people have been kind of disappointed by that in that Facebook group. There was lots of people that would get onto the group and they're looking for support, and they'd say, hey, first time user, and we'd ask, first time Formbot user or first time printer user, and they're saying first time 3D printing user. And then there's a lot that needs to go into kind of helping that person along to get them where they need to be. I mean, you certainly can, but again, it's kind of, this printer for your first one is like getting a Ferrari instead of a Honda Civic right out the door as your first car. Yeah, you probably can drive it, but you're not going to be able to drive it to its full extent. And you need to start somewhere else. You need to start on that lower, more basic one before you can get here. So, final thoughts on this. This is a great printer. It really is, especially for the price. This is inherently a clone of the G-Create G-Max 1.5 something. I mean, this one started a few years back, and G-Max has improved there since then, and so have they, and so has Formbot. They've diverged in what they do. I don't believe that the G-Create G-Max actually has dual extrusion yet, but this one does. It's got the independent dual extrusion even, which is fantastic. I mean, obviously it's very similar in design to like the very popular CR10 from Creality, which, although it's much more expensive. I will say though that from what I've seen, the parts quality on this is really great. It's, as I've noted, it's got ball screws instead of just your standard sort of threaded lead screw. So there's a lot less. There's a lot less friction on that whole Z-axis. Everything's really super solid. The parts are sturdy. You know, the bearings are all nicely lubricated and in high tolerances. So, you know, everything's really great about it. But like that G-Max that this is essentially a clone of starts, I mean, I think in the high 2000s, whereas this one starts around 1600, maxed out with all the features. It's right about $2,000. So for that, it's a really great deal for what you get. Assuming, however, that this is not your first printer and you are okay with being able to kind of dig in and tinker with it. I think that one of the things about 3D printing technology these days is, you know, you've got a wide range of capabilities, and these smaller 3D printers, kind of like what we've been used to, those are the ones that now for, you know, maybe sub $1,000 will have all of the bells and whistles and a lot of cool features, like the new Prusa Mark III. It's got all sorts of, you know, filament sensing. It can detect when there's a power outage without any external things or battery backup. It does all of this cool stuff, but it's also a much smaller build volume. Although at the same point, I mean, that's an even bigger build volume than the printer I bought 4 years ago, than the old MakerBot Replicator 2 that we had. And then you've got something like this, which has a massive build volume. I mean, it's basically 8 times bigger than the Prusas, but twice the price. So it depends upon what you want to pay for. But with this one, it has a lot of bells and whistles compared to a printer 4 or 5 years ago, but it doesn't have all the ones of a smaller printer that maybe is, you know, half the cost. This is a great platform if you want to be able to sort of tinker on it and modify it and use it as a base to make it to be the printer that you want, which, as you've seen, I have, and I'm still going to be doing stuff on it. You know, probably the first month and a half of this was spent printing stuff for the printer to do modifications on it, which is fine. I'm completely happy with that. So, you know, should you buy this? It depends on what you want. Do you want a giant printer that can do enormous things with, you know, a lot of flexibility at a relatively low for the size price? Or do you want something that you pull out of the box, you put on your desk, and you really don't think about it and never do any modifications to it except for general maintenance ever? If the latter's the case, don't buy this one. If the former is, definitely go with this. I will note, however, this one's dual extrusion. This one's got some really high quality parts to it. However, they do have one that's about half the price. I think it's starting around $800 and $900, called the Raptor. It's from the same company, Formbot. It's the same exact physical size, but it's single extrusion, and I would say from what I've seen of it, it's just sort of lesser quality parts. Like, it's lead screws instead of the ball screws. It doesn't have as nice of a heated bed. You know, everything's just a little bit lesser, made a little bit more to cost. I think that what they're trying to do with that is compete with the CR10, which, I mean, is still even probably half the cost of that yet, but it is a smaller printer. I do believe that there is a larger CR10, which I think is closer to the price of the Formbot Raptor. So, you know, there are options there if you want this size, but you only need single extrusion on it. That's really all there is for now with this. That's my thoughts. I hope you enjoyed it. All of the information should be, for everything I've talked about, all of the GitHub repo and Facebook group and all of the modifications that I've done should be down in the description of the video. And thanks for watching. Bye.